All right. Unit 5, stoichiometry. So we're going to take a combination of everything we've done so far. We'll build up to naming, balancing, and we're going to be able to now convert between grams, molecules, moles of a substance to grams, molecules, and moles of another substance. The mole. Scientists came up with a unit to count atoms, molecules, etc. It is called the mole. So because atoms and electrons and all that are all so tiny, can we actually count them? No. Even if I have a tiny little cup of water, can I see the molecules? No. All right? Even in a drop of water, you have million, billion, gazillion molecules in that one little drop of water. So, in order to make that easy, in order to count it, we now have the mole, right? So, you know how when you go to the store and you buy eggs, you buy them by the what? Dozen. What does dozen mean?
12.
12. Well, the mole is going to represent a really big number as well. All right? So, obviously, we don't want to use 12 because would 12 tell us much when it comes to atoms and particles? No, we still wouldn't even be able to see a group of 12 little molecules. So, the mole is a way of quantifying a really big number into something more manageable, just like 1 dozen helps us quantify groups of 12. So, how do we measure things in chemistry? Just to use some comparisons. For instance, we use mass in grams, right? We measure volume in liters. What are some other things that's not listed up here?
We measure feet.
We measure distance in
feet.
Not
Meters.
Meters. Yes, that's a universal measurement. And then another example, we can count particles, atoms, and molecules using moles. All right, so that's the way we're going to count how many we have. Ew. Not this lovely kind of mole, not the little blind guys that crawl underground.
The ones on people.
But what is a mole?
Okay, today we're going to talk about the mole. Now I know what you're thinking. I know what a mole is. It's a small, furry creature that digs holes in the ground and destroys gardens. And some of you might be thinking that it's a growth on your aunt's face with hair sticking out of it. Well, in this case, a mole is a concept that we use in chemistry to count molecules, atoms, and just about anything extremely small. Have you ever wondered how many atoms there are in the universe or in your body, or even in a grain of sand? Scientists have wanted to answer that question, but how do you count something as small as an atom? Well, in 1811, someone had an idea that if you had equal volumes of gases at the same temperature and pressure, they would contain an equal number of particles. His name was Lorenzo Romano Amadeo Carlo Avogadro. Wonder how long it took him to sign autographs. Fortunately for Avogadro, most scientists didn't accept the idea of the atom, and there was no way to prove he was right. There was no clear difference between atoms and molecules. Most scientists looked at Avogadro's work as purely hypothetical and didn't give it much thought. But it turned out he was right. By late 1860, Avogadro was proven correct, and his work helped lay the foundation for the atomic theory. Fortunately, Avogadro died in 1856. Now the thing is that the amount of particles in even small samples is tremendous. For example, if you have a balloon of any gas at 0 degrees Celsius and at a pressure of 1 atmosphere, then you have precisely 602 sectillion gas particles. That is, you have 6 with 23 zeros after it, particles of gas in a container. Or in scientific notation, 6.02 times 10 to the 23rd particle. This example is a little misleading because gases take up a lot of space due to the high kinetic energy of the gas particles, and it leaves you thinking atoms are bigger than they really are. Instead, think of water molecules. If you pour 18.01 grams of water into a glass, which is 18.01 milliliters, which is like 3.5 teaspoons of water, you'll have 602 sectillion molecules of water. Since Lorenzo Romano, never mind. Avogadro was the first one to come up with this idea. Scientists named the number 6.02 times 10 to the 23rd after him. He is simply known as Avogadro's number. Now, back to the mole. Not that mole. This mole. Yep, this number has a second name, the mole. Chemists use the term mole to refer to the quantities that are at the magnitude of 602 sectillion. This is known as a molar quantity. Atoms and molecules are so small that chemists have bundled them into groups called moles. Moles is hard for students to understand because they have a hard time picturing the size of a mole, or 602 sectillion. It's just too big to wrap our brains around. Remember our 18.01 milliliters of water? Well, that's a mole of water. But how much is that? Exactly what does 602 sectillion look like? maybe this all. Exchange the water particles for donuts. If you had a mole of donuts, it would cover the entire Earth to a depth of 8 kilometers, which is about 5 miles. You really need a lot of coffee for that. If you had a mole of basketballs, you could create a new planet the size of the Earth. If you received a mole of pennies on the day you were born and spent $1 million a second until the day you died at the age of 100, you would still have more than 99.99% of your money in the bank. Okay, now we sort of have an idea how large the mole is. So how do we use it? You might be surprised to know that chemists use it the same way you use pounds to buy grapes, deli meat, or eggs. When you go to the grocery store, you don't go to the deli counter and ask for 43 slices of salami. You buy your salami by the pound. When you buy your eggs, you buy a dozen eggs. When we hear the word dozen, we probably think of the number 12. We also know that a pear is 2, a baker's dozen is 13, a gross is 444, and a ream of paper is, anybody? A ream is 500. Well, a mole is really the same thing. For a chemist, a mole conjures up the number 6.02 times 10 to the 23rd, not a fuzzy little number. The only difference is that the other quantities are more familiar to us. So there you have it, the story of the mole, Avogadro, basketballs, and how to buy salami at the grocery store.
What is a mole? It is used to measure the number of particles in a sample. So 1 mole equals 6.02 times 10 to the 23rd atoms, particles, molecules. It's because those three can kind of be used interchangeably because those are 3 things that need to be measured in large quantities to even make a significant measurement, right? So particles, you don't really have a lot until you have a mole of that amount of particles, right? If I just had a dozen particles, I'm not even probably going to be able to see it. All right, so atoms, particles, and molecules are all teeny, 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 tiny building blocks of matter. And so 602 septillion particles give you 1 mole. So let's talk about first, before we go to that next blank, how do you enter this in your calculator? Go ahead and get your calculators out. If you don't have it with you, you are going to need your calculator this unit. If you don't have it today, we'll get through, but you need to have it. You must have your calculator. You cannot use your phone for your assignments. So let's take a look at your calculator. We're going to talk about how do we punch in times 10 to the 23rd. Because we may end up with 3 or 4 different things that we're multiplying. And if you punch it in, like times 10 to the 23rd, your calculator at some point is going to get confused. It's like, am I multiplying? Is it scientific notation? What do I do? And if you don't put parentheses in the right spot, it will get messed up. So your way of making sure you don't mess up is replace times 10 with an E. I'm going to tell you which E button to use, and we're going to make sure you use the right one so that you don't make any mistakes moving forward. So in your calculator, type literally 6.02. You can do 2 or 22. It doesn't matter. And then hit the second button and the comma button that has like the EE right above it. And you should end up with a capital E, just like that. Should not be the little e. That is not the correct E. And then type a normal 23. You do not need a caret. You do not need an exponent. You do not need any of that. You don't need times. You don't need 10. You just need 6.02 E23. And that tells your calculator that it's scientific notation. Go ahead and hit enter. It should shoot the same thing right back out to you. And I'm going to make sure. If it gives you an error, you typed in something wrong. You will see me write it both ways, but a lot of times I'll write it with the E. 1, it's shorter, and 2, it just helps reinforce that you need to type it in with an E. All right, so what is the mole? That number we just learned to type into our calculator, the number we've been talking about. What is it? That is Avogadro's number. That's the guy who came up with the mole. But like I said in the video, unfortunately, they didn't realize he was right until after he was dead.
So he didn't get any credit.
I mean, he gets credit now, but not when he was alive.
That's nice.
He could not boast about his discoveries. All right, so there's your cute little avocado's number of guacamole to go.
That looks so yummy.
So, Avogadro's number, So if I add a little picture here, I don't know what happened to it, but here's your cup, and you've got some sugar in your cup, okay? Little teacup. And my formula, I know the name of it, what its common name is, and if I were to weigh this cup out, and I had 180.15 grams, if I weighed that cup out and just the sugar in it, then that would mean I have 1 mole of sugar, or 6.02 E23 particles, 602 septillion particles of sugar. 602 septillion little molecules of C6H12O6 in that cup of sugar. All right, we'll talk about how we got to that the mass for grams there in a little bit. But another example, water. So, we've got a cup of water. If I were to weigh this water, and I said that it weighed 18 grams, I put it on, and tells me I have 18 grams of water in that cup, then that would mean I have 1 mole, or 6.02 times 10 to the 23rd particles of H2O. That means in your cup, and we can get out a cup and weigh 18 grams of water later if you'd like, but you would have that many little particles of H2O. All those zeros behind it. All right, so that's how moles help us, right? Because you don't want to deal with this number, right? You'd much rather say, oh, I have a mole, instead of writing that big, long number. So, in order to convert between moles and particles and mass, we need to know base units. Base units just mean what is the standard. So if I just have 1 mole, how many particles do I have?
6.02 times 10.
Yes, 6.02 times 10 to the 23rd, 602 septillion. And we often say PAM, particles, atoms, molecules. All right, an atom would just be like having 1 hydrogen. That's an atom. A molecule is like H2O. Particles could be any little pieces of it, ions, cations, anions, compounds, molecules. All right, so particles is kind of more all-encompassing. Now this mass one that we're going to look at today. Notice there's no number for the base unit of mass, right? Because if I have, in the video they use donuts and basketballs. So if I had 6.02 E23 donuts, here's my donut. I'm going to give it some sprinkles. All right? And then I had 6.02 E23 basketballs. Do they weigh the same?
No.
No. Just like does a dozen pieces of bread weigh the same as a dozen eggs?
No.
No. So that's why you don't have a number here for molar mass, because it's dependent on what molecule you're talking about. So molar mass is the mass of that given element or compound. Where can we find the mass at? On the periodic table. Yes, good job, Sam. On the periodic table. So on your periodic table, it's the number beneath. The one written on the wall over here is just formatted a little different. It's this tiny number in the corner. We talked about this unit 2, I believe, so this may be a little refresher on where you find your atomic mass at. But that is your average atomic mass. When you're rounding these, you're going to round to the nearest half. Almost all of them are going to go up. Almost all of them are going to go up to the next whole number. But you will see, for instance, chlorine is 35.45. So if I'm rounding to the nearest half, what does that round to? 35.5. All right, nearest half. So let's look at a mole of magnesium. I've just got magnesium, so it's the mass of that given element. So what's the mass of magnesium? 24. Round it to the nearest half, which is just 24.0, right? 24. So if I had 1 mole of magnesium, if I went in the chemical closet back here and I grabbed some magnesium, or that magnesium ribbon that we had in the lab, and I cut off a strip that weighed 24 grams, then I would have 1 mole of magnesium. All right, and I would have 602 septillion particles. Sodium chloride, this is a compound, so now I need to add them together. 22.9 rounds up to 23 plus, oh, here's that chlorine. Remember, nearest half, 35.5. All right, and so what would be my total?
35.5.
It says 35.45, and you need to go to the nearest half.
Why wouldn't you have done 24.5?
24.5. 3. It's 4. It's 4 and 6 would round to 5. If it's anything under 4, go down. Yep. And you'll only see that on a few. But 3 go down to 0. Yep. Good question. All right. So then add these together, and what is the mass of 1 mole of sodium chloride? 58.5. All right. So again, if you were to see 35.4. 35.5 and 35.6. Those will all round to 5. All right? Most of them all round up to the whole number. So that leads us into one-step molar conversion. So draw this in that little empty space. You don't want to take up all your space because you're going to have something else, but draw this little conversion table. And right here is your given number, unit, and name. Always start with your given number, unit, name. All right, this one is always blank. So if you want to put this here so that you can remember it, this is always blank. All right, so let's get into these. Identify your given and find. So they're going to give you a bit of information, and you're going to be asked to find something else. It may say you have 2 moles. Find the particles. So Johnny, there's your question about the 2 moles. You're given 2 moles. Find how many particles. You're going to follow your conversion path and build a dimensional analysis table for each conversion. Well, today, we only have one-step conversions, right? So, that's why your table only has one little line. That table, you have one line in your table for one-step conversion. Multiply across the top, multiply across the bottom, and then divide those 2 numbers. All right, so let's take a look at what flow chart it's talking about. All right, so we've talked about moles, right? So before we look at anything else, just look at it before we start drawing. We've talked about moles, right? And we know there's how many particles in a mole? 6.022 E23. I'm not sure what happened here. There we go. All right? Yes. And then we talked about the mass. All right? Then we talked about the mass, or the grams. How do we identify that? The bottom number, the molar mass of the molecule. So we may need to add it up. If it's just one molecule, we can look at our periodic table. All right, so notice these 2 things in the center are what is on your table for your base units. See how it says your base units, and it's like the molar mass of the molecule, or 6.02 E23. So go ahead and draw this in that empty space. Please make sure your top arrows are pointing outward and your bottom arrows are pointing inward. We'll talk about why. Some of you will need this flow chart. Some of you may not, but I highly, highly recommend it. about it, if I have 1 mole, and I want to know how many particles I have, it's 1 times 6.02 E23, right? Well, now if I have 2 moles, what would I do? 2 times, good job, Wesley, yes, 6.022 E23. All right, same thing going the other way if I'm going from moles to grams. If I've got 2 moles, I'm going to multiply it by the mass of one of them, and that gives me the total grams. And then going back, I would divide. So let's look at why we put that on the top and bottom as we build our chart. So let's look at an example after we look at each factor needs a none. All right, number, unit, name. So by number, I mean when you write 5, all right, unit may be a mole, and then name, you might have 5 moles of SO4. All right, so number, unit, name is needed on each box of that little table we drew. All right, so example 1, how many particles are in 2 moles of oxygen? So first thing, let's identify our given and find. How many particles? If they're asking me how many, is that what they gave me or what they wanted me to find? They want me to find. Are in, and the number is almost always your given. They gave you 2 moles of oxygen. All right, so identify your given and your find. Go ahead and write that down beside where you have given and find at. And once you've written that down, draw that table that I gave you, right? Step 1, identify your given and find. Step 2 was what? Somebody flip back and tell me what step 2 was. Follow your conversion path. So if you want to write it at the bottom so that you have it, so you don't have to flip back, we have grams, we have moles, and we have pan. All right, remember our top ones go out. Think of them like eyebrows. They're going out. Bottom ones are coming in. All right, and we use our 6.02 E23 on the right, and we use our molar mass on the left. All right? So, what did I say always goes in this top left one? Okay. The given. All right, so you're given number, unit, name, 2 moles of oxygen. All right, and now following that conversion path, what change are we going to? What did they give me? They gave me 2 what? 2 moles, and I want to go to where? Particles. So this is why I said make sure your top arrow is pointing outward, because whatever is on the top stays on the top. So when you fill out your conversion table, that's what's going on the top. Top arrow, what goes on the top? Say it louder.
6.02.
6.02 E23. We're talking about particles of oxygen. Number, unit, name. All right, it may seem a little redundant to write the name right now because we're dealing with the same substance, but you need to get in that habit because we'll be switching substances later on. So, this is what I'm given, and I want to find particles. So if I have 2 moles, remember we said you're going to multiply by the number of particles to get there. But you need to cancel out, right? Because also, if we just multiply these together, we have 1.204 mole particles, right? That's like X and Y. You have to keep them. So on the bottom, we need to put 1 mole. All right? Why? Does anybody know why? There's 6.02 E23 particles in what? 1 mole. That's your base. Notice these are your base units. So if you flip back, these are the base units you put in your table. This is your base for particles. This is your base for mole. And we said I need to be able to cancel my units out. So in math, if you have X over X, what happens? They cancel each other out. Well, we have moles over moles. So we get to cancel those units out.
And you always leave that one blank.
Yep, always blank. So, look at your steps. We followed our flow chart. We created a dimensional analysis table for each conversion that needed to occur. What's step 4? Multiply across the top and multiply across the bottom. So when it says multiply across the top, multiply 2 and 6.02e23. When it says multiply the bottom, you don't have anything there for now, so it's just your 1. So that's what you're multiplying. 6.02e23 times 2 should give you 1.204 e what? You can round it off. Where, it doesn't matter. Let's not tell you.
1.204 E24.
Yep, divided by 1. All right, well, anything divided by 1 is
Itself.
itself. So 1.024 E24 particles, because that's what I was asked to find, particles of what? Oxygen.
No.
Because that's what, when they punch it in their calculator, 2 times 6.02 E23, that's what the calculator gives you. When you have your calculator, you'll see that. Yes. All right, so here in your notes, like if you need to review this in Canvas, it's in your notes. Here it shows you, well, look, I'm at moles. I need to get to Pam. And here's your table that you should have drawn as a result. There's those moles cancel out. Your numbers don't go away. It's just canceling your units. And then there's your final answer. All right? Next example. If you have 8.9, 10 to the 35 particles, given or find? Given, particles of water. How many? What do they want me to find? Moles. So identify that as your given and find. All right, look at that flow chart that you probably wrote down. And we're looking at the side that deals with moles and Pam. All right, I'm not going to write the other side. You know what that is. All right, so moles to Pam and Pam to moles. And what conversion factor, what base do I use? Yes, 6.02E23. Good job. So go ahead and fill out that table. Remember, I only have one arrow here. So I only need one step in my table, which is that one line that we draw. All right? So here's that one step. Here's that one step. And I have 8.9, to save space, I'm going to put E, 35 particles of H2O. And because my arrow is going down, it's the down arrow, where am I going to put 6.023? On the top or the bottom?
Bottom.
On the bottom, because it's my bottom arrow, right? I need to divide. This is how many particles I have. I want to find the moles. So, 6.023E23 particles of H2O are in how many moles? Are in what? 1 mole. All right, so we're going between moles and Pam. So moles is your other box. Whatever you left empty is your other box, is your moles. All right, so just think of this the same as like if I said you had 36 inches, how many feet do you have, right? You would then divide by, there's 1 foot with 12 inches, and you would divide. Same concept. So multiply across the top, multiply across the bottom, which there's nothing else there, and get your 2 answers, and divide. So you should have 8.9E35 divided by 6.02E23. And what did you get?
1.477914.
1 point, give me 2 decimal places.
1.48.
I got 1.49.
Did you round it up? 1.4,
I have the point
you got 1.478, and then it rounds up.
Yeah. And
E.
E12.
12. And then that's what? I need a number unit name. That's what?
Moles.
Moles It's a lot of moles of what? H2O. That's your final answer.
Oh, this is pretty easy.
Good. Let's do 2 more examples.
Can I go put eye drops in?
Wait. So, find the what? Mass. That is what I want to find. And I'm given what?
6.7
Moles. Yep, of SO3. Yes. Sulfite. SO3. Alright? So, look at your table. I'm just going to draw the gram side. I have grams and I have moles. And remember, the top one goes out. Think of like eyebrows. Bottom one comes in. And I've got to use molar mass to convert. Alright? So, I'm given, I've got 1 step, so I just need 1 little table. Alright? And I'm given 6.7 mole SO3. Number, unit, name. Now look, I am going from moles to mass, or to grams. Mass and grams, same thing. Alright? So, where am I going to put my mass?
And the box to the right of mole.
At the top, right? But do I know what mass to put there yet?
No.
So as soon as you see mass in a problem, as soon as you see anything dealing with mass or grams, you should go ahead and find the mass of the substance it's talking about. So we've got SO3. So I have a sulfur, an oxygen, right? Let's add them up. How much does sulfur weigh? 32.059, so 32. And then oxygen is 16 or 15.9, so we're going to round it to 16. So that's 48 plus 32, which gives you 80. Yes, 80 grams. That's how much 1 mole of SO3 would weigh, is 80 grams. So, I'm going to plug my 80 grams into the top because my molar mass needs to go on the top. All right, 80 grams of SO3. Everybody understands where I got the 80 from? All right, and then on the bottom, I'm coming from what? Moles. I need my mole to cancel out. So that means that I have to have moles on the bottom. Whatever goes up must come down. So now you see my units cancel and I'm left with grams. So multiply across the top, multiply across the bottom, and divide. So you get divided by 1, and what's 80 times 6.7?
536.
536. So 536 divided by 1 is 536 grams of SO3. So, in 6.7 moles, you would find 536 grams of SO3. Are we doing good?
Yeah.
All right. Last example, we're just going to go practice the other way. Okay, last question. How many moles are in? So how many, they want me to find what? Moles, and they gave me grams of water. Yes. So what I say, as soon as you see mass, what should you do? See, I see a grams here. That refers to mass, right? So what's the first thing I should just go ahead and do because I'm going to need it?
Sure.
Go ahead and find your mass of the molecule, right? Well, what is water's molecule?
H2O.
H2O. So water is H2O. I have a hydrogen, and an oxygen. Hydrogen each weighs 1, and oxygen 15.9, which rounds to
16.
So how much does water weigh?
18.
You will remember that by the end of this unit, I promise. You'll see water 1,000 times. All right? So that was our first step because we know we're going to need it once we see grams. Because we look here and we see, oh, I'm going from grams back to moles, and I need to use the mass of that molecule. So,
So would that go on the bottom?
go ahead and identify your given 129.6 grams H2O. And that goes on, what goes on the bottom? Remember, it's my arrow on the bottom, so it's going to go on the bottom. And what's in the center right here tells you what's going in the bottom. So what's going on the bottom?
18 grams of H2O.
18 grams of H2O. Bottom arrow, and this tells me what goes on the bottom. 18 grams of H2O. I'm going back to moles. I want to find moles. So what's the base unit for mole? For mole, not particles. 1 mole. All right, here you see your gram cancel and gram cancel because whatever goes up must come down. Multiply across the top. Write your answer. Multiply across the bottom. Write your answer. And you end up with 129.6 divided by 18. And Annie, you got that answer?
7.2 grams of H. No.
We're finding what? Grams canceled. I'm left with moles. 7.2 moles of H2O.
So if we're going to grams to moles, we put the grams on the bottom and the mole on the top.
Yes. So follow your arrow. This arrow down here tells you whether or not to put it on the top or the bottom. If it's the top arrow that you have to follow, then you're putting it on the top. If you're following the bottom arrow, you're putting it on the bottom. So for this one, we went grams to moles. So I needed to divide by grams so that my grams canceled out and I'm left with moles. So this arrow tells you where to put it. This tells you what to put there.